Okay, so this is just like a bit of a run through. This is on this is for non-linear. Okay, so basically non-linear just means like it's a curve. I'm just going to have a look at three different graphs. You're going to be familiar with three different graphs. We've got the parabola, the circle, and the exponential. Okay, so the parabola, the basic equation for the parabola is y equals x squared. Okay, so if you look at that, that looks like that. That's the basic shape. Y equals x squared. Okay, the circle, x squared plus y squared equals r squared. So r is equal to the radius. And on this circle there are two squares. See? So you can recognise that there's two squares on it. If you drew it around like that, that would look like a circle. The parabola, if you went like that, that would look like a parabola. Maybe that helps. That's an x squared. So that's got one square. This has two squares, an x squared and a y squared. The x, and we all know what a circle looks like. There's the radius, minus r and minus r. The exponential, well, the exponential looks like that. The exponential basic equation is anything like a to the x. So a number to the x, 2 to the x, 3 to the x. Okay, so it's like reaching for the stars. That's the exponential, and it goes through 1 all the time, because when x equals 0, 3 to the 0 is equal to 1. Okay, so I'll just draw these. These are your basic shapes. So you've got parabola, exponential, and circle. So just pause the video and see if you can look at these and just name which one is which. Okay, so number 1, that one is the parabola. Number 2, the one that reaches for the stars, is the exponential. And number 3, the one that looks like a circle, well obviously is a circle. Now I'm just going to write down 3 equations. And stop the video and just see if you can match the equations to the actual shape. Okay. So this one here, see, exponential, that goes with that one, exponential. Y equals x squared, that's your parabola, looks like that. And the circle, well the circle is the one with the 2 squares on it. Okay, so first of all, just have a bigger look at the parabola. So with the parabola, the basic shape of the parabola is like that. Now if you add a number to the parabola, all that it does, it moves all of the y values up, so it'll move up 3. If you subtract a number, like say minus 3, that one will move down 3. If it was a 2 and not a 3, if it was minus 2, then it would just move it down 2. Okay. Now, if I put a minus in front, it goes from being a happy face, which is up, to being a sad face, so it just flips it. If I put a number in front, like a number bigger than 1, it will make it steeper or skinnier, like that. The bigger the number, the steeper it is. So it's steep, it's really skinny. If I just put like a smaller number less than 1, say 0.5, or you could write it as a quarter x squared, so if you've got a smaller one in there, that will widen the parabola, so it makes it wider. So let's have a look at a couple of graphs and let's just see if you can quick sketch them. You could pause the video if you want, just to see how you go, and then I'll do the solutions. 4 minus 3x squared, that's a bit harder one. And let's go 2x squared minus 1, and then y equals a half x squared plus 1. So what do you think that those graphs look like? And got to think about why. Okay, so if you look at this first one here, it's got one square, so it's a parabola, and then it has to go down to 4. This one here, one square, so it's a parabola, so it has to go up 1. It's got one square parabola, but it's got a minus, so it's sad. Now this one here, it's probably worth it rearranging it. This one would be sad. It would be skinny because it's got the 3 there, making it go up really steep. And the 4 just means it goes up 4. They go up to 4, skinny and sad. This one here, you go down to 1, skinny, and it is happy. So it's probably a bit skinnier than that. So it would be like this, going through -1. This one here would be a wider parabola, and up 1, it goes through 1 and it's wider. Okay, and then the exponential, doesn't matter what that number is, they all have the same, it all has the same effect. Reaching for the stars looks like that one. Okay, it goes through 1. Every single one of them will go through 1, because when you put in x equals 0, anything with a power of 0 is 1. 3 to the 0 is 1. Now, when you have a negative on that indice, it's the same graph, it's just flipped over, so it just goes down instead of going up. If you have 4 to the minus x, it goes down instead of going up. Now, for the circle has the 2 squares. But you do have to remember that this one here, that is, the formula for it is x squared plus y squared equals r squared. So r squared is 4, so r is root 4, which is 2. So that's the radius there. So what you've got to do is you put 2, 2, and minus 2. 2, 2, minus 2, minus 2. So let's say x squared plus y squared equals 9. The radius is the square root of 9. It'll be 4. Because what do you square to get 9? 3. 3 squared is 9. So that's why that's 3 minus 3 and 3. Let's just do one more. So x squared plus y squared equals 16. What do you square to get 16? 4. 4 squared 16, so that'll be 4, 4, minus 4, and minus 4. So just one last time. Say you had y equals 2 minus 3x squared. That was your parabola. X squared plus y squared equals 4, and y equals 2 to the x. Okay, so this first one, it has 1x squared, so it's a parabola. I think with these harder ones, you've just got to put them in the other order, because it's plus 2 minus 3. So it'll be sad, it'll be skinny because of the 3, and it will be up 2. So sad, skinny, and up 2. This one here is a circle. What do you square to get 4? 2. So it's a circle through 2, 2 minus 2. Centre 0. This one's an exponential. It's a positive one, so it goes through 1.